I'm Deepika Ladki, Assistant Professor, MBB, Capital Swing, Nashik. Let's see the topic video on predictive models. Predictive models is used to incorporate ways to help incorporate improved means of having good interaction with users. Predictive models includes keystroke level model, throughput, and Fitts law. Interaction is there are 6 behavior models that help SCI designers to predict the way an interface will behave and if it is effective enough to be used on a computer or a device. These are 6 behavior models are split into 2 categories, predictive and descriptive. In this video, we see predictive models. What is predictive models and types of predictive models? Predictive model is a simple term. Predictive model is a strategy that is used anticipating what will happen without the use of conducting research and postponing the release of an interface. While many are able to have a test run of an interface. There are few key models of predictive models. First is KLM. KLM stands keystroke level model. This is used to predict how long it takes to execute a specific task, and this is broken down into 3 areas. First is the carrying out of the operations such as pressing key buttons, using your mouse to point in an area, or drawing some things. Second is thinking about doing something. So before you actually get it done, you need to think about it. And the less time you need to think about something, then the quicker you can actually carry out the action. And third is the final area is how long it takes the actual system to do what you have asked it to do, which will happen after the task 2 steps. KLM is the operation for keystroke level model. The specific model identifies the low level actions that are taking place. KLM separates the whole process down into a single action. There are various actions, for instance pressing buttons on a keyboard, the movement and positioning of the mouse, and finally the interaction between a keyboard and mouse. All of the actions that take place have a fixed time in order to work out. Feedback that will be provided by the system. The keystroke level model was described by Card and Neville in early 1980s. The model focuses on how long it takes user to actually use the SCI via hardware. The keystroke model features 11 steps that is used by individual people and organizations and use these to estimate how long it takes to perform simple tasks involving the input of a human via hardware. Normally, companies who cannot afford specialists use this method. Why use the KLM? Consider a task such as delete a file. Perhaps there are 2 ways to do the task. First is mouse plus menu selection and second is keyboard plus command. The KLM can predict the time for each method. If you used at the design stage, design alternatives may be considered and compared. The choices follow. A KLM prediction. A task is broken into series of subtasks. Total predicted time is the sum of subtasks as given in box. The operators are K is keystroking, P is pointing, H is homing, D is drawing, M is mental, and R is system response. This is exactly what a keystroke is used to check for and to measure how long it takes for key to be pressed, for how long it will take a user to release the key, therefore showing how quick a typist the user is. The time taken to move your mouse to specified area on the screen. Just like the key press, it also is used to see how long it takes for you to carry out and release a mouse click. How long you need to change hardware devices such as keyboards or install a portable hard drive. How long it takes to type a string of characteristics. This will be used alongside key presses to set an accurate measurement for how quick you can actually type. Finally, it will also measure how long it takes your system to recognize what you are doing and to actually carry out what you have requested. So this is keystroke level model. Some operators are omitted or repeated depending on the task. Next model type is throughput. TP is the abbreviation for throughput. This is mainly linked to the output that is being given by the system. The role of throughput is used to measure quantity, or in other terms speed, that it takes to process can carry. The speed of processes can vary. The reason for this is because it is depend on the task that is a system has been requested or the level of sophistication that is involved. In other terms, this is also known as response time. This is used to show the overall productivity of the computer, how well a computer performs. It is used to show how quick a computer responds to a command. Therefore, showing you the computer's processing speed and allowing you to yourself determine if it needs to be upgraded or not. This is therefore known as response time. And as a computer gets older, its response time will gradually get higher. For example, when you add more things or material, soft copy material on your hard drive and install more things, software than is you are trying to search for a specific document, then it could take a bit longer to carry out the action. This is the same as when you are trying to start your computer up. Over time, it will take longer to actually turn on, and therefore it will decrease your personal productivity. So this is throughput model. Next type is Fitts law. This is a strategy that is used to work out and calculate throughput beforehand for any system design. This is done by forcing human movement and motion. This is works by the use of time and distance. In addition to this, the user time will also be different. The reason for this is because this is dependent on the user. In relation to where the icons are, the menu or actual UI, the movement and the click of mouse or using keyboard. This is used to predict how quick user will be able to move to a specific area based on how far away it is and how large the object you are trying to reach is. This creates a direct correlation between time and size, as well as time and distance. As further away you get from an object, the longer it will take to get to the object, and the smaller an object it is, the longer that will also take a user to reach the object. This can be shown in a few different ways. You can do this by pressing a screen using a touch screen option, or by using a pointing device such as a mouse. By sticking a Fit's law, you will need to choose buttons carefully, as they will need to be sized properly, and likewise positional property as well. So this is Fit's law. These are the references from I taken this material. So this is all about the predictive models and their types. So if you like this video, like it, watch it,